Today our class is instrument about synthesized function generator and oscilloscope. Here is the contents. First, we'll introduce what is the main feature of synthesized function generator and how to use it. Then, we'll introduce the most important instrument in electronics, oscilloscope. A oscilloscope can help us to measure lots of things like peak value, frequency, peak-to-peak, duty, gradient of a signal. It is a powerful tool to help us to analysis signal. One synthesized function generator. 1.1 What is a synthesized function generator? The synthesized function generator is usually a piece of electronic test equipment or software used to generate different types of electrical waveforms over a wide range of frequencies. These waveforms can be either repetitive or single-shot, which requires an internal or external trigger source. Some of the most common waveforms produced by the function generator are the sine wave, square wave, triangular wave and sawtooth shapes. Show in Fig. 1.1, a typical synthesized function generator. 1.2 What are the main features of a synthesized function generator, in addition to producing sine waves? Function generators may typically produce other repetitive waveforms including sawtooth and triangular waveforms, square waves, and pulses. Another main feature included on many function generators is the ability to add a DC offset. Function generators are used in the development, test, and repair of electronic equipment. For example, they may be used as a signal source to test amplifiers or to introduce an error signal into a control loop. Function generators are primarily used for working with analog circuits. Related pulse generators are primarily used for working with digital circuits. Counter up to 150 MHz high frequency. 1.3 What do the buttons on a synthesized function generator mean? Show in Fig. 1.2, a synthesized function generator front panel. Table 1.1 contains a summary of main display of a synthesized function generator. Table 1.2 contains a summary of entry keys of a synthesized function generator. Table 1.3 contains a summary of knobs of a synthesized function generator. Table 1.4 contains a summary of outputs of a synthesized function generator. Table 1.5 contains a summary of control knobs of a synthesized function generator. In Table 1.1 to Table 1.5, we'll introduce some functions that we mostly use. 1. Duty, for square waveform only. Indicates that the duty cycle is being edited. 2. -20 decibels. Indicates that the waveform output is attenuated by -20 decibels. 3. Wave display, indicates the waveform shape, sine, square, and triangle. 4. Shift, indicates that the shift key is pressed. 5. Frequency unit, indicates the output frequency, MHz, kHz, or Hz. 6. Wave selection, selects the waveform shape, sine, square, and triangle. 7. Key entry. For example, 12 MHz, press 1 + 2 + MHz. 45%. Press 4 + 5 +%. 8. Attenuate 20 decibels, attenuate the waveform output by -20 decibels. 9. Editing knob, increases right turn or decreases left turn the frequency or duty cycle. 10. Cursor keys. Moves the editing point left or right in case of manual editing. 11. Power switch, turns the main power on, off. 12. Waveform output, outputs sine, square, and triangle waveform. BNC terminal. 50 ohms output impedance. 13. Amplitude, attenuation control, sets the sine, square, triangle waveform amplitude. Turn left decrease or right increase. When pulled out, attenuates the sine, square, triangle waveform amplitude by -20 decibels. The -20 decibels display turns on. 14. DC offset control, when pulled out, sets the DC offset level for sine, square, triangle waveform. Turn left decrease or right increase. The range is -5 volts + 5 volts, in 50 ohms load. 1.4 How are the outputs and terminal connected? Show in Fig. 1.3, BNC terminal, 50 ohms output impedance. Show in Fig. 1.4, the square wave outputs from TTL, comms output. Show in Fig. 1.5, the arbitrary wave outputs from output. 1.5 How to use a synthesized function generator. First, show in Fig. 1.6, power on the generator and select the desired output signal, square wave, sine wave or triangle wave. Second, connect the output leads to an oscilloscope to visualize the output signal and set its parameters using the frequency, amplitude and offset controls. There are two methods to adjust frequency. Using entry keys panel to enter the desired frequency. Rotating editing knob to set the desired frequency. Show in Fig. 1.7. Rotating AMPL knob to increase clockwise or decrease anti-clockwise the desired amplitude. There are two steps to set DC offset level. Step 1, show in Fig. 1.8, when offset knob pulled out. Sets the DC offset level for sine, square, triangle waveform. Step 2, show in Fig. 1.9, rotating offset knob to increase clockwise or decrease anti-clockwise the offset level. Third, attach the output leads of the function generator to the input of the circuit you wish to test. Final, attach the output of your circuit to a meter or oscilloscope to visualize the resulting change in signal. To Oscilloscope 2.1 What is an oscilloscope? An oscilloscope is a device that lets you view changes in voltage over time. When you have circuits that have constant voltages, a multimeter is a tool that can be used to measure a single number for the voltage. This becomes redundant when you start building more complex circuits. This is where an oscilloscope comes in handy. An oscilloscope allows you to view how voltage changes over time. These voltages are called signals, which are used to convey information. Some of the things that the display screen on an oscilloscope shows the measured signal of the voltage using a graph. The voltage is represented on the vertical axis and time on the horizontal axis. 2.2 What are the main functions and features of oscilloscope? Voltage measurements. Time and frequency measurements, pulse width and rise time measurements, phase shift measurements. Oscilloscopes are used in the sciences, medicine, engineering, automotive and the telecommunications industry. General-purpose instruments are used for maintenance of electronic equipment and laboratory work. (2.3) What do the buttons on an oscilloscope mean? A typical oscilloscope shows in Fig. 2.1. Oscilloscope, default setup show in Fig 2.2. When you push the default setup button, the oscilloscope displays the CH1 waveform and removes all other waveforms. The default setup button will reset all setting except for the following. Language option saved setup files saved reference waveform files display contrast calibration data printer setup -232 rupees setup GPIB setup. Oscilloscope, volt, div. The volt, div knob amplify an input signal so that a division represents a certain voltage. A division is the distance between two lines of a square on the oscilloscope's screen. Show in Fig 2.3. Rotating the volt div to increase clockwise or decrease anti-clockwise the scale of the y-axis. Oscilloscope, SEC, div. The SEC, div knob determines how long the electronic beam that draws the curve takes for moving from the left to the right edge of a division. The knob controls the time scale. A division is one square on the screen of the oscilloscope. Show in Fig 2.4. Rotating the SEC, div, to increase clockwise or decrease anti-clockwise the scale of the x-axis. Oscilloscope trigger. The oscilloscope trigger function enables repetitive waveforms to be displayed on the screen in steady fashion. The trigger enables the time base to start its scan at the same point on each repetition of the waveform. In this way, the oscilloscope trigger enables the waveforms to be viewed in a meaningful manner. Otherwise, the time base would start at a random point on the waveform each time the waveform is repeated, and the image of the waveform would not be meaningful. Show in Fig 2.5. There are 3 steps to use trigger. First, press Trig menu. Second, select a trigger source signal. Final. Rotating level knob to set the trigger level set in the middle of the source signal most of the time. Oscilloscope, save, recall. To save or recall a setup or waveform, press the Save, Recall button and then select either waveforms or setups with the storage softkey. Show in Fig 2.6. Select the setup or waveform memory location number 1 number 10 with the setup softkey. Then press the Load or Save softkey. Oscilloscope measure. You can use the built-in measurement functions to confirm these values. Frequency period mean PK cycle RMS min max rise time fall time pause width neg width. For example, you want to measure the frequency of CH1, press the Measure button up in the menus of the control panel. Show in Fig 2.7. Press the Channel Selection button to make sure that channel is the currently active trace. Show in Fig 2.8, on the menu on the right side of the screen. Select Frequency by pressing the Unlabeled button right next to the item in the menu. This is just like ATM machines at banks. Select the More menu item to see other options. Keep hitting the More button until the high and low menu items appear. Select these. Oscilloscope, cursor. You can measure waveform data using cursors. Cursors are horizontal and vertical markers that indicate x-axis values, usually time, and y-axis values, usually voltage, on a selected waveform source. The position of the cursors can be moved turning the entry knob. When you press the cursor's key, it will illuminate and the cursors will turn on. To turn cursors off, press this key again until it is not illuminated. Cursors are not always limited to the visible display. If you set a cursor, then pan and zoom the waveform until the cursor is off screen. Its value will not be changed, and if you pan the waveform back again it will have the cursor in the original place. When should we use cursors? Measure voltage difference between cursors delta V. Measure time difference between cursors delta T. Measure reciprocal of delta T in Hertz 1 delta T. There are two cursor types: voltage type press cursor button shown in Fig 2.9, select voltage type shown in Fig 2.10, select the source signal means the signal desire to measure. Rotating position knob to measure the distance between cursor 1 and cursor 2. The difference between cursors means the voltage difference. Time-base type press cursor button shown in Fig 2.9, select time-base type shown in Fig 2.11, rotating position knob to measure the distance between cursor 1 and cursor 2. The difference between cursors means the time difference. Oscilloscope, utility show in Fig 2.12, activates the system utility functions, such as system info, self-calibration and selecting a language. How are the outputs and terminal connected? Show in Fig 2.13, BNC terminal. Measure method like a synthesized function generator.